right, it's time to multiply radical expressions this time. And we are just going to start by writing some steps. All right. Step 1, you're going to multiply the coefficients. Okay, that's the first thing. So you're going to do that using the laws of exponents and any other rules that you need to use. You're going to multiply the inside of radicals with the same index. So that means you can't multiply a square root by a cube root. But if you have the same index, you can multiply the inside. And then you're going to simplify the resulting radical. So let's do a simple-ish example to begin. 3 root 10 times negative 2 root 18. So like I said, you're going to multiply the coefficients. 3 times negative 2 is negative 6. We have the same index. They're both square roots, so we're going to multiply the insides. 180. And then from there, we're going to simplify. So 180 is 9 times 20. I already know this one's a perfect square, so I'm going to keep it there. 20 is 4 and 5, and hey, that's another perfect square. So remember, these are like mini square roots. And now we're going to go through and fill in everything. So we have negative 6 that we began with. The square root of 9 is 3. The square root of 4 is 2. And we have left the square root of 5. Multiply all these. Negative 6 times 3 is negative 18. Negative 18 times 2 is negative 36 root 5. So that's the deal with multiplying radical expressions. So let's do one more that does not have variables. All right, I would recommend that you pause the video and try this problem and then come back and check your answer. Welcome back. All right, so the rule is that we need to multiply the coefficients. Negative 3 times negative 1 is positive 3. They have the same index, so we're going to multiply the inside. 64 times 8 is 512. Now again, I do not have the fourth root things memorized, so I'm going to go and do this long style. So 512 divided by, obviously 64 and 8 will work because we just multiplied those together. 64 divided by 4 should be 16, and 8 is 4 and 2. I'm going to go all the way down for this one. 4 and 4, 2 and 2, 2 and 2, another 2 and 2, this is a lot, and the last 2 right there. I'm going to do this the more complicated way to me, but it works better for me for this kind. I'm going to count up all my 2's. 1, 2, 3, 4. 1, 2, 3, 4. And one more. And since it's a fourth root, we need to take out groups of 4. So that's a group of 4. 3 times 2. There's a group of 4 times another 2. And the fourth root of 2, because that does not have enough. 3 times 2 is 6, times 2 is 12. So 12 times the fourth root of 2. So multiply and simplify. That's basically the process. Let's do one with variables now. All right, so we have the cube root of negative 3 a to the 7th b to the 4th times the cube root of 36 a to the 6th b squared. So we're going to multiply coefficients, but we don't have any, so that's just 1. And now we're going to multiply the stuff inside. So we have negative 3 times 36, which is 108, negative 108. We have a and b, and when we're multiplying, we add exponents. So 7 plus 6 is 13, and 4 plus 2 is 6. At this point, we simplify. So go ahead and simplify, and then pause the video and simplify, and then come back. All right, so I just went through and got everything into perfect cubes or not, and now I'm going to go through and fix those. So the cube root of negative 27 is one I have memorized. That's negative 3. The cube root of a to the 12th should be a to the 4th. Divide. 12 divided by 3 is 4. The cube root of b to the 6th is b squared, because 6 divided by 3 is 2. And now we're going to go ahead and write our leftovers. We have 4 and a. And that's it. Hopefully you got it right. If you have any. All right, so there's 2 more types of examples that we need to do when it comes to multiplying. And one of them would look something like this. All right, so this is a distributing problem, and that's actually what you need to do. So the first thing you should do is check and see inside. Can I combine like terms? No, these are not like terms. So now we're going to follow distributing rules. So we're going to distribute the square root of 10 into the radicals. So with 10, the square root of 10 times 5 root 5, 1 times 5 is 5, 10 times 5 is root 50, minus 1 times 2 is 2, 10 times 2 is root 20. And from there, we need to simplify. So we're going to simplify 50. I see 25 and 2, and I see 4 and 5 here. And we can't combine them yet because they're not like terms. The square root of each of these little guys, we're going to have the 5 that was right here. The square root of 25 is 5, and the square root of 2, minus 2 times the square root of 4, which is 2, and the square root of 5 stays the square root of 5. We're going to simplify. 5 times 5 is 25 root 2. 2 times 2, negative 4 root 5. We cannot combine these because they are not like terms. All right. One more example. All right, so this one is multiplying binomials. So we need to do all the multiplying first. Some of you might use FOIL. I tend to use the box method. I mean, myself, I would use FOIL, but a lot of you also learned this, the box method. So I'm going to go ahead and show it box method wise. All right, so we're going to put our little terms on top and on the sides. And then we're going to multiply to fill in the boxes. The square root of x times the square root of x is just x. Essentially, it's the square root of x squared, which is just x. Negative 1 times 1 is negative. The square root of 8 times x, 8x. Again, the square root of 2x. And the last one will be the square root of 16, negative the square root of 16. So we're going to take all these things out over here on the side. X minus 8 root x plus 2, or root 2x. No, I just wrote the 8 in the wrong place. Minus the square root of 8x plus 2x minus root 16. We're going to simplify anything that we can. So our x is great. 8 is 4 and 2. So the square root of 4 is 2 root 2x plus the square root of 2x. That one can't simplify. Minus the square root of 16, which is 4. We can now combine these middle terms because they're the same. So x minus 1, the square root of 2x, minus 4, which obviously we don't need that 1. So the best way to write this answer would look like this. So you can use the FOIL method even when you are working with radicals.